All right, we're talking about voltage regulators.
Yeah.
So number 2 is going to be voltage regulators. Number 3 is going to be voltage regulators. Just warning you right now. I go, wait, we already did that. Okay. The voltage, V-O-L-T-H, voltage output of a generator, is dependent on 3 things. 3 things. 1, 2, and 3. 1. What?
Voltage regulator?
Nope.
Oh.
Speed the armature rotates. The faster it rotates, the more violent you can say, or the more rapidly the wires are cutting across the lines of flux created by the field poles. So, through 2, number of armature windings. The more wires you have cutting through the lines of flux, the more voltage you will get, or the higher the output. And the strength of the what? Magnetic field. Can I move? I should probably get better at saying, why are we going to even care about this? Why are we doing generators on these old planes? I will tell you this quick story that, so you know, I worked in an overhaul shop. Well, we did the whole thing. I mean, we did restorations, antique restorations, ground up. I mean, you guys know what a basket case is?
Yeah.
It's not. So it's
Something
just
comes to you in a basket, basically.
literally the project comes to you in baskets. We would have people pull up with a trailer or a truck, and they would have just this wire cage. It would be just tube cage, and you can kind of look at it and go, well, I recognize that there's sort of a slope and a tail would go there, and then just carton after carton, box after box of just stuff and cobwebs and rats and whatever. Go, well, here's my airplane. You know, I'll send you money every month and call me when it's done. And we would build this whole airplane up. And it just seemed inevitable we would get done. And it would be gorgeous and beautiful. And, you know, these fully restored Stearmans or Cubs or Piper PA-12s at Cubs, Super Cubs. And, you know, the fresh engine would get bolted up. And it's like time for it to start it up. And everybody gather around. We start it up. And generator didn't work. You know, and then somebody come, well, because you got to flash the field. We're going to talk flash the. So I guess I'll push that and do that and hook these wires and still doesn't work. Well, then it's just like this procedure. 1, try it. Overhaul it, number 1. Overhaul it, put it on the aircraft. 2, try it. 3, randomly push stuff and connect wires. 4, remove and send to George's Electric. 5, reinstall and test it works. It was just like this procedure that we'd always do. And it's like, because the people didn't understand exactly how to treat generators and how to make them work and what was working with them. So by not understanding very small nuances, they burned up all the voltage regulators. It was just constant. So you don't want to do that. It was one of the things I just kind of stayed away from because you did your thing. But then when I was in charge, I said, we're going to do one of 2 things. First, we'll go to step 5 and send it right out to George's Electric. Was a place over in Rio Linda who was an aircraft certified repair station, and so we would send generators and alternators there, have him do them, put them back on, put them on, they work. Let the specialists do the specialist things. All right, where was I here? B, there are 3 elements. There are 3 elements to control. So talking about voltage regulators, you got 3 elements to control. With this 4 on a twin. 4 on a twin. So let's say 1, speed of the armature rotates. No, move down a bit. 1, you got to control voltage. can't go putting 28 volts in a 14-volt system.
That's silly.
It will burn up all of the lights, destroy all of the avionics. Current?
I'd be pissed.
Yo, I bet. You got to control the current. You have to limit the current going out, because if you draw too much current from the generator or ask too much of it, you're going to overheat it, and it will look like that. All the windings come out. Or a generator is actually a motor running backwards, if you will. Not backwards, but it's just wired different. So you can actually take a battery, hook it up to a perfectly good generator, and it'll start motoring. It's a weak motor, but it will work. So if the generator output is less than the battery and you connect it, so in other words, it's connected to the engine, so it won't actually do anything, but if you took it off of the engine and just set it aside but let all the wires connected, and if it didn't have a proper voltage regulator and you hit the master switch and turned on the aircraft electric, the thing would sit there and start moving. So now if you actually take it and put it on the aircraft engine, it's like a little trolling motor, and it gives you 1 horsepower extra. And you don't want that. So you have to be able to shut it down if the current isn't correct. So you got to limit the current going out of it, and you have to stop it from going into it. 2, 3. Oh, that was this one, and that's reverse current. You can't have reverse current. Don't want it to go back. You don't want it to be a motor. And if it's a twin, let's be for twins. In other words, you have 2 engines, you have 2 generators, you have to equalize it. So you need an equalizing circuit. Otherwise, one carries the whole load. You would think that it'd be like, well, if you don't do it quite right and the voltage on this one, just a little bit more than the voltage on this one, then this one maybe will do a little bit more work than that one. It doesn't. It kind of takes the whole load, and the other one just doesn't do anything. So you have to equalize them out. So all right, let's talk specifically about voltage regulating. I guess we'll voltage. I'll call it that, so it looks different. So, all right, there are 3 basic types of regulators. There are 3 basic types of regulators. We've got the solid state, which would be the more modern, electrically controlled, no moving parts. Why wouldn't you have this kind of thing? And the oral of that one would be, well, you hook this wire up, that one, stuff happens on the inside. If it doesn't happen on the inside, then we take it apart and put a new one on. There's the carbon pile, which you might remember. We talked about a carbon pile from before, or battery, I think it was, and the vibrator type. All right, the operating principle of all 3 is to control the field strength. So the operating principle of all 3 is to control field strength. If you control the strength of the magnets, you control the generator.
1 F and all.
What's that?
The 1 F and of.
All right, talk about the vibrating type. I'll let you get caught up. We'll go to this slide. I think that's what I want to talk about. Let me see. Close enough. I can talk about this one for a second. So this is a very simplistic version of controlling the field. So we have, again, the armature, the brushes. We have it going out to the load. The load is the aircraft. This is the negative load, the positive load. But this would be contained, I can do it like this. So this is sort of the generator right there. And then this right here is the regulator. And then it goes out. So it's two different pieces. All right, so what's happening here? Again, very simplistic one. So is it shunt wound or compound wound or series wound? Well, how did you know that?
Just a feeling.
Okay, just a feeling. Shunt means parallel. So is this in series with the load? That'd be no. Okay. All right, so if I can control the field, I control the output. So in this one, basically what I would have is just a, again, it's a very simplistic type. So I would have something like this with volts. And it would be pilot controlled. And it would have a little needle on it. And we would say, well, that needle's got to be somewhere in this little green band right there. So, okay, as long as the needle is, change color, within the green band, we're happy. So I start turning on a bunch of loads, and what happens is the generator is only putting out maybe an amp or two, is charging the battery, and now I turned on landing lights and this and that and the other thing, and the fan in the toilet and whatnot. And so what are my volts going to start doing? It's going to go down and down and down because I've held the generator at a certain output. I said, nope, you're going to stay right where I've set you. So I start losing my volts, and it starts dropping below the green. So me as the pilot with my controlled rheostat, remember rheostat is nothing more than a variable resistor. What do I need to do? Adjust it. I got to turn it up. So I go this way. This way would represent, if it was right here, it'd be like no resistance. So I got to turn it up, which allows more current to flow through here, more current to flow through the field. More current through the field is going to mean more output. Now, it doesn't just do like volts or amps. You control the volts, and by doing that, you kind of control the amps, is the way it works. It's sort of like, I wish we could have done more with batteries with you guys, but if you're charging a battery and the battery's kind of dead, and I have a battery charger, and I can select either constant potential voltage or constant current, set the current. This is kind of like setting the potential part. So what happens is on a battery that's kind of dead, if I set it at 14 volts, it will put out 5 or 6 amps, and then as soon as it starts building up and it's not dead, then the amperage will stop. So by turning up the volts, I'll increase the amps on this. By turning down the voltage, I decrease the amps. So you're just controlling the voltage that way. And as long as you keep the volts where it's supposed to be, it'll keep producing more and more amps as it needs it. Hopefully that made some sense. It did in my head, and that's all that really matters to me. All right, so a very simplistic type. Oops, I think I wanted to go to this one actually next. So, all right, there we go. So this one is more of an automatic type. So now we remove the monkey. And the other one, you have to actually literally hire a monkey, and the monkey just sits there and he's trained to move the little thing back and forth, kind of like the carburetor monkey, right? Okay, so they haven't heard the carburetor monkey yet. So, all right, so this one is the vibrating type. And so again, it's kind of the same thing. We have a shunt wound field. We had the same thing before. Let's see. Notice that there are some terminals here. You kind of got to get used to these. Like A plus means the load. Armature plus, that's the battery plus. You have A minus, that's the output. Usually A minus, in this case, would just be grounded to the case. It's just automatic, but they drew it in here. And you have an F plus. Well, there could be an F plus, there could be an F minus, but what is it saying? This is the field, and what does the field want? The field is being provided a positive. It's grounded down here. The field doesn't need a ground, it needs a positive. So that's why it's F plus. Are you watching the game?
No, I took a picture. of
Okay.
the game
That's what I figured. Well, it's a good tell us the score, dude. All right, so here we go. So what happens is we have some points, and this is a little spring with an adjustment on here. And this creates a magnetic field that acts on the contact points. So what we could do is set this up so that how would I want to do this? We could do these as normally closed, which means in the resting position they're closed. And I'm just thinking it through as I go here. And what would happen is as the generator output exceeds what I want, let's say I don't want it to go above 14.5 volts. As soon as this gets above 14.5 volts, it would create a electromagnetic pull on the points and open them up. Say, no, you don't. Too much. And so these would open up, which would kill the power going to the field coil, which would then kill the generator. Just shuts it off, right? Sort of, except there's a little magnetism built up. So it would shut it down. Well, now as soon as I shut the generator down, what happened to the voltage? That went down. Well, guess what happens here then? Well, you just lost voltage. It takes 14.5 volts. I'm making that number up. 14.5 volts to keep this open, so it went below 14.5 volts because it opened. So now it shuts. So now the current starts flowing back through here again. And then it starts building up to 16 volts. Well, what happens here? They open up. So it's going to sit there and just vibrate at the speed which keeps... So it's kind of like going down the road, and you're not allowed to actually keep your foot on your gas pedal, but you're allowed to bounce it. Why would you do that? I don't know, but I drove with somebody who did that once, and you could just... Be like trying to drive at 55. So bring it up to 70, back off to 45. Bring it up to 70, back off to 45. You know, it averages out. Trust me. All right. Hopefully you see how that works. Now this is an adjustment so that let's say that the spring starts getting weak. You're finding out, well, it used to be at 14.5. Now I'm only getting like 13 volts out of it. I want a little more. You can go in there and you can adjust this up a little bit and get what you want. So it's a mechanic adjustable thing inside this little box. So that's all there is. Now there is a resistor down here because if we follow this through, what's happening, we should have a couple of, I'll go this way. So here's the path. One is direct output right there. So that's a generator output. So I can find a path through generator output with absolutely no resistance whatsoever, max power, or come down here through resistance, which just throttles it down a little bit. So now it's not all or nothing. It's a lot or a little bit less. A lot, a little bit, and it's be easier to regulate it that way if you did something like that. So that's all there is to voltage. Remember, you got to keep the voltage from going too high. Now, this doesn't take into consideration the other things we're going to deal with, but it's a good place to start. What's next? Carbon pile. Might as well talk about while we're here. A carbon pile is almost the exact same thing, except that you have a bunch of carbon discs here, which create resistance. And so the tighter they're pressed, the less resistance you have, and the looser they are, the more resistance you have. So this is just a variable resistor. And how do they vary it? Well, with magnetic impulses. So if we kind of follow this through, we would go B, which is considered battery in this case. We could come down through here and realize that just goes through the regulator, through the armature, through the A post, and would energize the coil right here. A is usually armature. I don't know why they call it A. I think it's because they're calling it points A, B, C, and D, maybe. All right, so it comes through here, goes through a variable resistor. Why a variable resistor? So you can control the output, adjust it on the ground. So this is an adjustment point for ground personnel. So we have voltage comes through here, winds through here. That will tighten it up and can create more resistance, or we have it backwards wound, which, oh, sorry, that's the equalizer bus. That's why it's backwards wound. So tighten it up. It will tighten up on its own, which let me think would be less resistance, or expand it out, decrease resistance, increase resistance. You increase resistance, you throttle down the generator, or decrease resistance and throttle up the generator. Hopefully I didn't screw that up for you. Okay. Equalizing bus is something else here. All right. We'll get to that. There it is. Okay. All right, vibrator type. Principle, 3 strength, vibrator type. Okay, and so that was a resistor is intermittently cut in and out of the field circuit by normally closed circuit breaker points in series with the field. So a resistor Resistor is intermittently cut in and out of the field, in and out of the field circuit by normally closed, that'd be NC, normally closed, breaker points.
Do those wear out quick because they're just snapping?
They do not wear out quick. They last a long time. In series with the field. Let me see. No, points in resistor are in parallel with each other, but are in series with the field. Nah. Okay. Oops, was that 5? There we go. That would make more sense. So the voltage coil. Oh, this is a good point. Voltage coil is connected in parallel with generator output. That's a very important point because when we look at as this generator we're building, because we're going to build upon it, we're going to add more and more coils, gets more complicated. You have to distinguish between something that is measuring voltage and it's measuring current. So if you go back 4, 5, 6 weeks ago and you had your Simpson meter, if you wanted to measure voltage, you would measure it in parallel. Good. Some people know better than to say anything. I don't know. So, yeah. So you want to measure your voltage in parallel. So every time we see something at a voltage regulator that's in parallel, we can automatically say that it's sensing voltage. Okay, and if something is in series, which you haven't gotten to yet, something is in coils in series, it has to be measuring amperage. Okay, so voltage coil is connected in parallel. You're going to look at it differently in a bit later when I say, well, what is this doing? And you look at it and go, well, wait a minute, that thing is in parallel, therefore it's measuring voltage. Okay, so you got to go both ways, back and forth. With gen output. Got it. Okay. As voltage increases to desired value, the coil opens the points. And what coil? That little tiny coil next to the points that opens the points. That's what's coil opens the point. Opens the points, and current opens the open points, and current to field must go through resistor. Must go through resistor. Okay, this drops the field current. This drops the field current. And lowers the magnetic strength of the field coils. And lowers, I have right here magnetic strength. I'm thinking about that. This drops field current and lowers magnetic strength. M-A-G-N-E-T-I, magnetic strength. And that's all I wrote in my notes. And so I'm thinking about that. This drops the current, the field current, and lowers the magnetic strength. Magnetic strength of what? Okay, number 1, field coils. Number 2, The vibrating points. Well, first it should be the magnetic strength. I should put of the field coils. So the magnetic strength of the field coils decreases. Therefore, the armature that's cutting through that field is going to have less output of the armature. Less output of the armature is going to mean that the voltage is going to go down. The voltage goes down, then it's going to have less of an effect on the voltage coil. There's less pull on the voltage coil. The points are going to spend more time closed, which will cause a generator to produce back up again, or produce the right amount. So you see this circular thing? You guys seem to be getting it.
The more we talk about it,
Huh?
the more I kind of get it.
Okay. Let's see. Well, let's keep talking about it then. That's what I'll do. As magnetic field drops, so does output, and the coil releases the points, which removes the resistor. Okay. As magnetic field drops, it should say the magnetic field of the field coils drops. Where am I here? So does output. So does generator output. So does gen output. And the coil, voltage coil, we'll say voltage coil, releases the points. Releases the points. Remember, they're normally closed, so they close, which removes resistor. Which removes resistor. And I could add here, current goes up, current to field coils goes up, current to field coils increases. So it's just going to sit there and, as thus the name says, vibrate to make it do this. Points open and close. Open and close. Many times per second. It's actually hard to see. You're gonna run a generator. Well, maybe you won't. I don't know. And
It's funny.
well, you'll do it, just maybe not with me or however Larry wants you to do it. So. All right. Okay. So that was that one. And anyway, you can't really, it's hard to see them actually vibrate. Carbon pile. Carbon pile voltage regulator. All right. Carbon discs are stacked to create, wow, I got so much crap here. All right. Carbon discs. Are stacked to create a variable resistor. A variable resistor. Variable resistor. One, as pressure on stack increases, resistance is lowered. Let's see. As pressure is released, resistance increases. As pressure is released, resistance increases. I always feel bad when I write so much, but I guess if I don't, then you kind of miss the points and you're like, I don't know.
I appreciate you writing it.
All right, then I'll take the time to do it. There is a spring There's a spring that places pressure on the pile. Remember, pressure on the pile is low resistance that is in series with the field. There is a spring that places pressure on the pile which is low resistance. Low resistance. That is in series with the field. All right. So a coil that is parallel with the generator. So here we have this with the gen. So here we have this coil, the sensing coil that's parallel with the generator. What is it sensing? Voltage or current? Everybody says voltage, because it's in parallel. Say coil in parallel with the generator. The output will counter the spring. As generator reaches proper output. So a coil that is parallel with the generator output will counter the spring as the generator reaches its proper output. So the spring puts pressure on the pile, low resistance, give me all you got. Throttle it up, bring on the juice. We got to get this generator going. The generator starts going, it senses the voltage. As the voltage starts to build up and reaches where it's supposed to be, this coil then counteracts the spring and starts pulling the pile apart. You pull the pile apart, the resistance starts to go up, you lose voltage, current going into the field coils, you lose voltage, current going in the field coils, the generator output does what? Down, and so that's how we regulate it. I'm just going to put this here. Equalizing circuit. So in a multi-engine aircraft, if the generators are not paralleled, that's what you call it when you equalize them. If generators or alternators are not paralleled, one generator does all the work. One generator does all the work. That is not good. You don't want that. So you have an equalizer that is added to this, and it's usually a separate item, and with an adjustment that's allowed in there. I don't want to go. I could do this, and it goes. I have a page and a half of how this thing works, and it's like it just will make you guys crazy, and you'd be like, I don't understand this. I don't get generators. I'm going to fail the test, and so now I'm just going to tell you. I'm not going to ask you how it works. So why bother? Now I would just tell you that it is extremely important that you parallel generators, especially on twins. You can't just change out a voltage regulator or change an alternator or change a generator and just go, there you go, have at it. You actually have to set up and you have to measure the outputs of them, and there's a box that's usually somewhere near one of the engines where you actually have an adjustment, and you will adjust which way it's going to go so that each generator has a very close exact matching output on their voltage. So when they have equal and output of their voltage, then they'll be working together instead of one just doing all the work and the other one just going, hey, thanks, man. I was trying to think of an analogy, but I'll let that go. So, You need to parallel them, and that's the point right there. If you can just get that, when you have twins, you must parallel the generator. And this right here is it's an old-fashioned non-solid state equalizing circuit. I don't know where you'd find this anymore, on a DC3 or on an original Lockheed Electra or something like that, or a Beech 18, Twin Beech. But otherwise, you're going to see more of a modern solid state one with an adjustment on it. And it's, of course, stands to reason that if you are paralleling generators and you pull out your trusty voltometer, it had better be
Equal.
calibrated.
Oh.
Anytime you're using something like that, you got to have it calibrated. So let me think. Equalizing circuit keeps the output of each generator matched. Procedure for matching is called paralleling. I wrote that. Modern aircraft has solid state. This is the non-solid state, and I go all the way through it, and I'm not going to do that. So it is actually quite complicated how you have these little tiny equalizing resistors, equalizing shunts, and how it drops a small voltage, causes a voltage to go through one of those coils, and the voltage, small voltage through one of the coils causes this to move right here, and then that regulates it. And like I said, it's complicated, and you won't enjoy it. So let's see, 7. Yeah, that goes on for like 2 pages. All right.
I'm sorry, what did he say?
What?
I'm just kidding.
I was going to say, well, I'm missing the joke. All right. All right, so I said we have to control 4 things in a twin. So one is,
Speed of
no, we don't control the speed of the generator. Yes, that's exactly how you run a voltage regulator. You get in your aircraft, and if you have too much voltage, you just pull the power back. Sorry that you're descending into a mountain, but you got to adjust. No, we don't adjust the speed. We adjust. Okay, so I know what you were looking at. So there's 4 things that we have to control, which is 1 was voltage, 4 was equalizer. Okay, we got those out of the way. So now we're off to the second one, which current, which shall be item number 4. So why not? Because I think 3 was voltage regulation.
Yes, sir.
So reverse current cutout.
I thought that was number 3.
Well, just roll with it, dude. All right. So as I stated earlier, if you hook up a battery to a generator, and it's one way to test generators, just hook the battery up to the generator, you put the positive to the armature, ground out the case in most of them, the way you hook it up, and boom, it just starts spinning, and it'll sit there and spin. It's not a great motor, but it'll work, and then you know everything's kind of working. And so same thing will happen in an airplane if you just turn on the master switch. But of course the generator is locked in either by gears to the engine or by a belt. So now you just kind of have a dead short going. And that is not really that good for it and or anything else. So you don't want to do that. So anytime that the generator output is less than the battery, we got to have some way to disconnect the two. Because before, all we were doing is controlling current going through the field, right? Okay, but you still have current, you still have the armature output is connected to the battery, because that's the way it's connected. So the minute you turn it on, did I have a drawing like that? Let me see. So it kind of looked like, so here's, let's do this one more time. So right there. So this is my brush. We have a field coil right here. So field coil brush, this would go to the battery, really. And then we'll ground out the case. So there, we got positive here, it comes back around. Got my field coil right here, which could go through a variable resistor of some sort. There, we just do it like that, variable resistor. And we can control the field. Does that look like it would work? Which is a very simple kind of a little thing right there.
Yeah.
So, I drew it. I don't know what the hell I'm doing half the time.
You're the master.
I just make it up as I go and hope that it works out. All right. So, there we go. Now I'm safe, right? Battery, this is completely out of the picture. It's no big deal. Yeah, everything's fine. So now you know in an aircraft, there's a master switch. So when you get into an airplane, I mean, you walk up to any airplane, it's pretty much off. There's no electrical power to anything. It's not like a car where you open the door and the lights come on, and put your key in, and the radio kind of works. It's not like that. You got a switch. And there's a switch, which is a solenoid that connects. Well, I didn't need enough room. You have a solenoid that then energizes the battery. Then the battery goes through the whole thing. And now my nav lights work and my instrument lights. And what else is going to work? The radios usually have a separate switch you have to hit also. What's that? Sure. Power is available to all that stuff, right? And so I get in and this is the master switch. So I connect the master switch. I turn it on. Yep. Boom. Everything in the aircraft is now powered up. So is the generator in this case. So what does the generator want to do? Well, right now the generator is going to see this and go, oh, look at that. I've got some current flowing through here. And by the way, I've got some current going through here. So I've got magnetism here, and I've got magnetism that's going around in the field coils in here, the armature. And so magnetism and magnetism, opposites attract and like repel, and so that's going to come into play. And so you're going to have a north and south, and what's it going to want to do? Start rotating the armature, but it can't. So now I just have this nice little dead short right here, and so the battery's only going to last for a very short period of time. But on the good side, once I get the engine up and running, and it's going to act like a little trolling motor, and like I said, give me another 2 horsepower, right? Because it's sort of a hybrid at that point. It was the original hybrid. It was all right. So what's that?
The Prius of planes.
It is, yes. So. I don't know how we're going to get the regenerative braking in, but that's a whole other thing. So I don't want that. This is not supposed to be a Prius over here. So we have to somehow disconnect this and say, well, wait a minute, you're not working right now, so I'm just going to disconnect that. And so there's no power going into the armature trying to drive it. So you don't want any power going, or any voltage or current, I should say. You don't want current flowing this way ever. That's bad. Current should only be a one-way thing. It should only flow out and go that way if we're doing positive or negative. So every time you go backwards, you got to shut it off. So that's why it's reverse current cutout. If the current goes the wrong way, stop it. And so what it's going to do is it's going to sense the current. Is it going this way or that way? It's going into the armature, bad. It's not a motor. It's coming out of the armature, good. That's what it's supposed to do. So let me see. In every system that has a generator that charges battery and supplies aircraft operating power, there must be an automatic means to disconnect the generator from the battery if the battery voltage is higher than the generator. I think I can abbreviate that too. There must be an automatic means. There must be an automatic means.
Put a Doid in there.
I was going to say a monkey, or you can train a monkey to flip a switch. Either which way. Must be an automatic means to disconnect the generator. Do you know why we don't want monkeys in the cockpit?
Why?
Because eventually they'll realize they don't need the pilot, and so this is not professional pilots. I'm talking about myself.
You can't teach monkeys to make good decisions.
Yeah, that's right. And you can't teach a monkey to make a good decision, but you can certainly pay them less. There was a joke that was something about the cockpits. The cockpits of tomorrow would have a pilot and a German Shepherd. The pilot is there to feed the German Shepherd, and the German Shepherd is there to bite the pilot if he touches anything. I like German Shepherds. So, means to disconnect the gen. That says gen right there. Gen. Yeah.
C. That sounds like.
I wondered what it said too, so I had to read the whole thing. Generator. Generator. That doesn't help at all that I did that. Okay. From the battery. From the battery, if battery voltage is higher than generator. Voltage is higher than generator. If battery voltage is less than generator, BRY, battery voltage is less than generator. There, gen. And is not disconnected. Connected. The battery drains into the generator. That is not a good thing. It is bad. A reverse current cutout. Reverse current cutout, RCCO. Reverse current cutout. Yep, now I can abbreviate it. Save time, see world. Reverse current cutout. Let's see. Will accomplish this. Is used. Just made that up there. Okay. D. So we have a voltage coil. Voltage coil and current coil. So you have two windings are wound on the same iron core. Are wound, W-O-U-N-D, W-O-U-N, wound on the same core. I have a voltage coil and a current coil. What does that mean?
One's in series, one's in parallel.
Yes, I love you. Have candy.
Oh, dude, sick.
It's coffee's flavored. Want some water too? No. Okay. Just trying to be helpful. All right, voltage coil and current coil wound on the same core. That means one is going to be wound in parallel and one is going to be wound in series on this same coil core. Would you like to see a picture of said before I get too far here? Or shizzles, okay. Reverse current cutout, there we go, from current slide. Now, when you look at this for reals, you will notice something very interesting, and that is that this voltage coil is literally very tiny and small wire because it is in parallel and has very low current going through it. You will notice that this one here is very, very fat because it's wound in.
Parallel.
Give me your candy.
I already ate it.
All right, you keep it then.
Yeah, you can take my Oreo.
Okay, try it again. This wire here is the voltage coil. It is very small because it is wound in parallel. And so how much current goes through it? Very, very little. This is wound in series with the whole airplane. All of it. So it's got to be very, very thick. So if the generator is a 20 amp generator, how much amperage can flow through this coil? So 50 amp, how much is going to go through there?
50.
So it gets a pretty fat piece of copper wire right there. So you can tell the difference. One is very, very thin, one's very, very fat. And it's wound on the same core. Can't see the time. Still can't see the time. I have what? 1 minute? All right. Really quick. So what happens is, as it says, the points are normally open, which means no current can flow. Because when I turn on the master switch to the aircraft and I get power, I don't want power running back through here, running through this, back around, and running the generator. Don't want it. So it's normally open. It says, nope, we're not going to open up until it's working. So I start up the engine. I get the engine going. I get up to the voltage regulator that we just talked about. It does its job. Says, hey, check it out. We got the proper voltage. Let's go. It's going. Proper voltage then works its way through here, down here. Now, it can't go this way because it's open. But it's going to find a way through here. Oh, just a little bit of current's going to flow through there, just enough so that, guess what? It pulls these down. Boom. So when this voltage coil is above the battery voltage, there will be enough current flowing through it to close the points and send current off to the battery, which is now less than the generator.
It's cool. Wow.
Right, so here's the voltage regulator. That's there, so you have to have this. So that's all there is to it. But I'm going to ask you this on the oral. Well, are these points normally open or closed? They're normally open. No, closed. No, open. No, I don't know. Okay, open. Right, what closes them?
Voltage coil.
Voltage coil. Yeah, I just blanks. So don't be that person. What closes them? Simple. This little voltage coil. Where's the voltage coil? Well, I can't really see it, but I know it's there. Or it's right there. Or something. But because sometimes it's wound behind that and you can't see it real well. Yeah.
Now, I don't know if it's just the picture, but would, when you turn on the master switch, would a little bit of current be able to flow back through the voltage coil?
Nope, because it's coming from this way. It gets to here and stops. Can't go. It's open. The only place it can come from is the armature plus, A plus, from the armature output. That's the only circuit that's still alive. Nice question.
When we start class tomorrow, can we go over this again?
Please.
Really? I just talked to you about it.
Really quick, just to refresh me.
Of course.
I know,